Okay, there we are. Hello, everyone. Welcome back. Oh, one second. I am feeding right back into my headphones. Okay, that is better. Now I don't have to listen to myself. Just you get to listen to me. Sorry about that. Tonight, gonna do something a little bit different. Circling back around to some of the .NET interactive stuff that I did. Welcome, Kenny. That I did back with some of the John and Diego. Wow, those names were a little hard to come by. Because they had got me going on this cool idea of how we could use .NET Interactive to go through and interact with, say, a WPF app. And so in real time, effectively be able to manipulate and get a nice visual feedback of what that looks like. So was going to circle back to that. The only problem with what we built before was that it required you to go through and add a bunch of stuff inside of your app. And most of the time, I don't want to do that. I want to basically just point .NET Interactive at a WPF app and say, sick 'em, and fire it up and start acting on it. Now, that's precisely what Snoop does right now, right? If you are familiar with the Snoop tool or see me use it much, you're familiar with the idea that when I want to go and mess around with the visual tree, I fire up Snoop, I just point it at my app and say, go. And it lets me in and I can play with stuff. So I got the idea of, well, let's see how far we can take this. So the code I'm going to be showing tonight is not actually pushed on GitHub anywhere yet. I'll get to why that is in a minute. But so just be aware, if you were hoping to follow along with the code, that's going to be a little more difficult. Before I get too carried away, announcement time. Hacktoberfest is coming. I love Hacktoberfest. I've done it for the last 3 years, I think, 4 years, something like that. So during the month of October, DigitalOcean puts on what they call Hacktoberfest as a way to try to get people excited and contributing to open source projects. And it's actually pretty cool. So if you haven't contributed to open source projects, or you're kind of looking for that easy quick start, this is a great way of doing it. The short version is if you commit, or if you open 4 valid pull requests, you get a free t-shirt out of it. So it's pretty easy. And you get a cool shirt out of it. Like the red one that you're seeing here is last year's shirt. So it's pretty cool, pretty fun. You're going to start seeing me on a lot of repositories. You'll see the Hacktoberfest label start to show up. All that is a way to communicate back to people, hey, these are good introductory issues. They're usually well documented on what needs to happen, good acceptance criteria, and usually a lot of pointers in them of, hey, look in this file, do this, do that, that kind of thing. So if people are interested in contributing to open source, I highly recommend you go through, drop your email in here. DigitalOcean doesn't really send you a lot of extra stuff, so you don't need to really worry about getting spammed. And extra facts and whatnot and all that kind of stuff. So the month of October, I'm probably going to spend a decent amount of my time on stream focusing on either helping people with existing pull requests. I know last year I did some talks on kind of getting used to using Git, opening pull requests, rebase, that kind of thing. So if people are interested in that kind of stuff, let me know. Always happy to talk about it. But for people interested, you can just Google Hacktoberfest 2020, or there's the link in the chat as well. So just be aware that is coming in the month of October. For people who are interested in material design, my plan is to have the 3.2.0 release out the door well before October, because a lot of the 4.0 breaking changes are simple to make, well documented. And so my plan is to label all of those Hacktoberfest. So if people want to contribute and jump in and help out, a lot of them are simple things like go rename this API. Simple, easy to do, but it's a good way if people are wanting to try and find their way into a new library. So bear that in mind, and I might see if I can con some coworkers into coming and doing it as well, because my company has a bunch of open source projects that we are planning on tagging with Hacktoberfest. So I might see if I can steal some of them. Kenny, I'm volunteering you. Okay, so what have I done so far? So the first thing to note, so if you go and download the Snoop library, and actually here, I will fire this up. So Snoop WPF on GitHub. So if you were to go and clone and download Snoop, you would get this project right here. Snoop, in my mind, for people who follow me on Twitter, is an amazingly well-designed open source project. I cloned the repository. I went down to the build PS1 script. I ran it, and everything just worked. It was glorious. So that, in my mind, that is exactly what an open source project should do, right? It should be very easy for me to clone and get started and work on stuff. And so I got in there, got working, everything built. I was like, this is awesome. Because ultimately what I want to do is take that bit of Snoop that lets me jump into a WPF app and pull it out so that I can use it for something else. And there's actually an existing issue about going through and doing that, effectively taking that injector that they have to get into the WPF app and breaking it apart into some reusable component. So at the end of the day, I may end up contributing some of this back just because this is starting to push it in that direction. But right now, there was a bit of a problem. So the code that I wanted to write, right, for this Snoop.NET Interactive, I wanted to reference the Microsoft .NET Interactive C# library. And that's not a bad thing. For people who watched my stream with John and Diego, you'll know that a lot of the stuff that we were doing is using preview versions of packages and latest releases and this, that, and the other, right? Which is fine. But the key part is it's a preview package. Now, Snoop is taking advantage of a new feature on NuGet called directory package props. So for people who have had to manage your NuGet packages and you're really annoyed that you can't just manage them in one place, you have to go project by project by project, this is the feature to solve that, right? And actually I can drop this in. This one kind of came out without a lot of that's not it. Where is the docs for this? This didn't get documented well and didn't get advertised well when it first came out. And I'm not entirely sure where it is. So I might have to go hunting for that. The short version is you get to manage your NuGet packages in exactly one place. So you'll note they've got this directory packages props where they get to declare, you know, maybe something different for different targets. But then I can specify the versions that I want to pull in for all of my projects. And then what does that do to the project? So let's go and pick on, like, say, Snoop Core, right? So if we go and look at the Snoop Core CS proj, we come down here and you'll note what we end up seeing in here is there's not a lot in here. Specifically, there's no NuGet references. Let's back up. Trying to remember what packages I just saw and where they would be used. Let's see. JetBrains annotations. Oh, is certainly used in there. So let's pick on, I don't know, Snoop console. Oh, right, because it's the shared bit, they aren't being referenced anywhere. So all of the NuGet packages get included for you so that you have reference to them, but you can manage them in one place. The problem with this feature is it doesn't allow preview packages. And just like the other directory .build props and .build targets, it's inherited by looking up the file structure. And so any project inside of this repository is going to inherit this, which is a big problem if I want to do something like this. Because the NuGet feature doesn't support preview packages. There's not a release. And I don't have a good way of opting out of the feature, at least not for what I saw. Again, the documentation on it's a bit lacking and clearly hard to find because it took more than 10 seconds. So what I ended up doing is saying, okay, I'm done with this. What I'm going to do instead is I'm just going to make my own project. I'm going to just pull it outside of the solution folder altogether. I will file link in the stuff that I want, and then I'll build my own thing. So that's what I did. So ultimately, there's a couple files in here that you'll see that are like this. These are not actually my files, right? You'll note there are file links here, the little blue. Hang on. Apparently, I didn't get Karnak open. I didn't get Zoomit open. I gotta get all the things going. Right? So the little blue arrow there, that indicates that the file is being linked into the project and is not actually part of the project structure. So, and then in our CS proj, obviously it shows up looking like this, where it's got a relative file link, but you'll note it's going up a directory, bumping out of mine, and then going into where I have Snoop cloned at, right? So this guy currently has to live alongside of a clone of Snoop rather than, you know, inside of it, which is where I would have preferred. Which is why this is currently not checked into source control anywhere, which is becoming kind of a pain because I want to work on multiple computers and I want to use Git. So at some point I might have to make a repository or figure out some fancy linking stuff to work around this, but ultimately that's the problem that I'm running into. So what does this end up doing? So in this project, I have this interactive class, right? And he has a static method. In fact, why is this not a static class? He should probably be a static class. Public static class. He has a static method that takes a simple method in here called start, right? And the start takes in just a process ID and a callback. Now this injector launcher manager, this guy here is largely just ripped out of the existing Snoop library. So he's technically my code, but a lot of this code is blatant copy and paste from within Snoop. So just be aware of that. So if it looks like it's confusing and complicated, it's because it a little bit is. But the key thing that it does is, so part of Snoop is they've got some native exes that they build called this Snoop injector launcher, right? And the whole point of this process is to get inside of the WPF process and give you a callback. So this guy will do all of the complicated bits about getting inside of the process. And then more importantly, he will turn around and invoke a callback that you give him. So this callback method will get invoked from a different process. So I will be outside of my process space and into a different process space. Oh, is that why that thing? Set C# variable, new interactive object. That's dumb. We'll just do that because this doesn't work yet. So this callback method, even though it looks like I'm just passing in a simple delegate, this actually ends up being a method info to my callback method, which is on start, which gets invoked. And this string settings file, again, is largely around me just mimicking what I was taking out of the Snoop library. They do a bit of parameter passing via write a file, invoke this other exe, give it the path to the file. That exe pulls the file out, reads the contents, back and forth. So kind of a convoluted way of passing a bunch of stuff. I imagine there is a cap for CLI invocation length. And I suspect that that's the reason for this settings file, is that they were potentially hitting that cap or just wanted to avoid it altogether. And so rather than doing it, they're basically using it like a response file for people who are familiar with that term. So that is where this guy sits here. Now the end goal, the end goal is, hang on, clear cell outputs, is I want to be able to write this, right? I want to be able to say, install my NuGet package, start this thing, and give it a PID, right? And ultimately this PID might actually end up going inside of this connect command or whatever, right? And then this guy should just connect, right? And everything should just work. I believe kernel name was supposed to be Snoop UI. So that's the end goal. And then after this point, hopefully everything is now set up inside of that WPF app, just like what John and Diego and I did, so that we can work and interact with it and query stuff and change stuff and do all kinds of fun stuff. But ultimately, the goal tonight is to just get the connection working. Now, the unfortunate part is this is a pain in the neck to debug. So in an effort to debug this, my current working thought is I'm just going to spin up a, and I think I moved this around, so I'm going to have to change it, right? So we're gonna just whack that real quick. My current thought is I'm just going to spin a quick CLI app, and we're going to try it there. That way it's easy to debug. So I think I'm going to have to add the project, and this is going to get a little weird. My fact that I don't have this in source control and that I don't have this in a reasonable sharing spot is starting to bite me enough times that I might just go through and do it. That seems like the prudent thing to do. But never let that get in the way of doing stuff. Always build cool stuff because that is what is fun. Why did you pull in assemblies? System reactive. Interesting. Wonder why that happened. Okay. So we've got a CLI. So this PID that I'm using right here, for anybody who's curious, that is this guy. All I did was take the material design demo app, fire it up, and went, oh, look, 36688, right? There it is right there. So, boom. So we're just going to try to connect to it because why not? I just need a WPF app that works. So that's where we start. Let the adventuring begin. Also, Mountain Dew, which unfortunately I upgraded my camera, which has made my green screen work better, which means my Mountain Dew is less visible than it was before. So trust me, this is a can of Mountain Dew. Here, we'll spin it. This is a can of Mountain Dew. Okay, here we go. In we go. Launcher. Get process by ID. I assume it was able to find it. Great. Get window handle. That is a valid, well, I should put it this way. That is a non-zero handle, so I'm going to assume it's the correct one. Because again, I didn't write a lot of this code, so I'm just going to trust that it works. And that is what happens when you close the thing you were working in. There we go. Okay, so we've got a process, we've got a method info. We don't have any transient settings data. I wonder if that will bite me. We shall see. Okay, process, get architecture. So this is getting the bittiness of the material design demo app, which it's running as an x64. Great. Is it running as elevated? I think the answer is no. Okay, that matches with what I would expect. Okay, and so now it's trying to get the declaring type, the assembly name, okay, as well as the name of the method to invoke. Okay, that all makes sense. Write to file is going to do nothing because there is no file there, and I wonder if I need to make a file there. We shall see. Transient settings file not equal to null. Okay. So location. So this is the current executing assembly. So this is inside of, so I am running Snoop CLI. Let's see, can I do, oh, I wish, how do I, boom. Oh, no bueno, no bueno. So the path here is my bin debug directory. So I'm assuming that we're okay. Let's keep going. We'll see. So that is the directory of where I'm at. Oh, and this guy is expecting to find the injector launcher in a bin build directory. I'm gonna go out on a limb and guess it ain't gonna find it there. Let's just check real quick. I'm fairly confident I haven't done anything. Yeah, this directory doesn't exist, so that's gonna be a problem. Because inside of that, it is expecting to find the Snoop injector launcher. Oh, I bet you I know why it's looking here. It's looking here because I have a NuGet package that I was trying to wrap this Snoop interactive up in, and it was going to look for it there. Maybe I need to change this so that I can pass in that value. Okay, we will. So this is just going to throw a file not found and say, what are you talking about? So it wants the Snoop injector launcher x64. I think in the interest of simplicity, we're just going to grab that guy. All right, so I'm going to, where is open path? Right, I'm just going to grab this build directory, and I'm just going to put it where it's supposed to be. All right, so that goes, we're just going to grab that build directory, copy, paste, and we'll just pretend that it's going to be there, because I want to see this callbacky thing work first. Okay, so we crash out. That's fine. Go again. Let's see. I don't think we need that. Let's just dive in here. Dive in here. I think we can run over the top of that. Run over the top of that. Okay, so that should now exist. Great. So we are going to invoke it, passing a few things. So this guy here, let's see. So this is using a different command line library to be able to go through and build this up, which makes me feel a little weird. But here's the invocation that it's doing. So it's got an assembly. It is passing a class. So assembly, Snoop interactive, class name, target handle, on start, there's the PID. And I wonder if it's making working directory changes. I don't think that's a problem. Okay, so it's going to start. And we exited right away. Where is exit code? Oh, invalid operation exception. That is, oh, because it's been disposed of at this point. That's not good. Okay, so here's what we're going to do. We're going to pin this guy here, pin this here. And I think what we might do, we might just go through and write one of these. I don't know if it's important to have this settings file or not. If 1 + 1 is greater than 3. All I want is an anchor point for a breakpoint. Right? And so we are going to launch this one more time, because I want to see, I don't know if not having that settings file might make this other thing die. That's a possibility. More importantly, now my process isn't out of scope, which means it hasn't been disposed. Come on. Give me that sweet exit code. Okay, what are you being dumb about? Process, expand. Thank you. That was a little. So that is definitely a non-zero exit code. But I don't know if it wrote me out any useful information. So let's do this. Let's grab this, and let's just go do this on the command line, I think. So cd Snoop CLI. So let's see, cd bin. Bin is spelled with an I most days. And let's check this out here. So cd net core app 3.1. And I'm going to just go and whack that. Let's see, slap a handle, process corrupted state exceptions on there, and pretend nothing happened. Oh, Kenny, what are we going to do with you? Hopefully that's not what's happening. I hope. So there's my, there's the arguments that are being passed. Injector launch. So I kind of want to grab you, because that's the path to the exe we're going to fire off. I wonder if I need to set working directory too. I don't know how it's going to find me appropriately, but we will see. So we will paste that in there. Yay, new Windows terminal that I have done almost no customization to. Let's just see what it does. Okay, so unhandled exception. Could not load file or assembly command line. So I'm wondering. So this guy attempted to do a callback. Well, hold on. Snoop injector launcher program main. So that is actually in the Snoop library. So it tried to fire up that exe, and that exe failed. So what's the easiest way to go about this? I think, let's just check my output directory, because I'm sort of wondering if all of that stuff should be in here, right? Right? Sorry, what was the output of that guy again? File not found. It wants command line. So I don't know exactly what that DLL is. But it is right there. So I'm wondering if I set my working directory to here, if that gets me around that problem. So go ahead and kill execution for the moment. Though on one hand, I'm realizing that when I ran it from here, this would be my working directory. So I'm going to guess that this guy is. So let's while we're in the interest of copy and paste mode, right? Right. Copy and pasting DLLs around has never been a bad thing. Let's just put that right there. And then I think I should be able to just run this again, right? Because this is effectively what it's going to kick off. I don't need my other app. Ah, okay. So this is interesting. So now it's gotten past where it wants, and it wants to be able to find my assembly. Interesting. So it must, okay, so I am curious now. I am curious how this other app works. So let's go into Snoop. Let's just fire up their solution. Open with preview, please. Because I'm very curious how this injector launcher works. So there's this guy here. This is the injector launcher that this is the program that we're ultimately starting. Again, there is some native generic injector stuff. So if people are interested in how to inject into a process's memory space, that's the guy. But we're not interested in that. We are interested in what this guy does. So his main gets invoked. He does a parse, map, and run. We fall into here. We know we got to here because we saw starting injector process, right? So that guy right there, starting the injector process. And then we got could not find DLL. So could not find. So injector data, full assembly path. So the key part here is it is trying to get the assembly path, and it looks in two places. This process wrapper or the command line options assembly. So let's start with this. Did we set command line options assembly? We did. Now it's interesting to me that what we set this to here on our CLI is just the name. And I'm wondering if that's not correct. I'm wondering if this should actually be location. We'll come back to that. We'll come back to that in a moment and just see. Let's take a little bit more careful look. So what is this? So get assembly path. So process wrapper, assembly name, or full path. So that seems to indicate I could pass a full path. Either that or that's a horribly named item, right? So if file exists, it'll return. So I could change that from the assembly name to its fully qualified path, and that would work. Otherwise, it does some lookups to be fancy. I think the easiest thing to do is just change that to the path of my assembly. Yeah, there's no reason to be fancy about this. Okay, so that's easy. So let's go. I'm gonna close you. I don't need you open anymore because I have you here. So I want to know where you are coming from. You came in through launch, and launch got invoked from here and here, and ultimately I'm looking for the thing after the int pointer. Assembly get name. So I think rather than this, location. Meh, what could go wrong? All right, so let's fire that guy up again, and let's see what happens. Okay, so I'm guessing you failed out, given that it's already exited. But what I'm really interested in looking at is the new command line syntax we got. So we've got this. Great. That's kind of all I need you for. Go away. Okay, so let's clear that out so we don't get confused. And then I'm going to just backspacey all of this stuff. Backspacey is the technical term. And we are going to just run that. Okay, so trying to load generic injector, trying to load generic injector in process blah, successfully loaded, freeing, successfully freed. System cannot find the file specified. So what happened? So Snoop injector launcher, Snoop injector line 299. I don't know if that gives me enough information, so let's go look at injector CS line 299. Injector CS line 299. 290. Huh? Not crazy, right? Not that those are mutually exclusive. Came from 56, so let's go up to 56 and see what that is. 56 inject Snoop, so that's not overly helpful. Came down here. Well, so let's see what we know for certain. Trying to load path to injector DLL, which we saw that. Trying to load injector DLL, and then we got trying to load injector DLL in process name. So blah 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 virtual alloc. Yeah, this is where the memory stuff gets fancy. And the native methods write process memory. That's the scary one. Let's see here. So there's that. There's that. That all comes in. That's fine. I'm just a little curious. Little library and form process. Okay, so here's where we got this log message. So we're now to here. Great. And I expect to see a successfully loaded somewhere in here. So it does some stuff, successfully loaded, then we return. Okay? So load library from form process, jump back. Okay, so we keep working our way down, and I assume received something from injector component was the next message. There we go. We are now down to here. And then I see trying to free module. Let's see here. So this comes into here. Received. Because this should have been non-H result from execute in default app domain. Oh, so this is not a good thing if it's non-zero. This is, let's see. Received really big number. I'm going to go out on a limb. That looks remarkably like -1. I could be wrong. But that tends to happen with native code. You get that over and underflow. I could be wrong. But that looks really, really close. It's that 2.14 that triggers. Okay, so that is, so this is actually the point where we erred. So it tried to do this with handle, but something went wrong. So we were able to create remote thread, wait for single object. What's in here? These are all native, get exit code, right? So there is all of that. A little confused. Where the heck? Load library and form process. So this is where we just were, right? And the last thing that it does in here, successfully loaded. Successfully loaded. Okay, and then received this from injector component. Okay. So what was it supposed to do and why did it not work? So all I know for certain is that this guy went to run and failed to inject. And it could have failed for any number of reasons. So let's go back here and let's figure out what is going on in this method. So trying to load, it does that. String for remote process, path to DLL. Right? So it's gonna build this up. It's basically gonna create a pin to the string. Remote virtual address, great. That seems fine. Write process memory. There's no way this causes problems ever. It's just blindly writing in stuff into another process's memory space. That's okay. Trust it. It works. Okay. So what is it writing? So it gets the process handle, gets a remote address, address of the local string, size, bytes written. So what string for remote process? Buffer length. I'm just trying to figure out path to DLL. Right? So this is what this is going to come in. So it's going to say try to load this guy. Right? And I think what we saw, trying to load this guy into process, the generic injector. So I guess the question is, do I have everything I need in that output directory? So let's take a look at what, when you compile Snoop, what do you end up with in here? Nothing. Okay. So let's just pop this open. Wrong drive. cd dev, cd Snoop WPF, and I'm just going to run the build script again. Because I don't, when I did this before, I was on a different machine. And I'm a little curious. Like, look at that. Even in its startup script, it's got pretty art. Like, you can't make it better than that. Well, that's a lot of red. Failed to do a lot of things. Snoop interactive. C# error project dependency does not contain an inclusive lower bound. Blah 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 blah. Okay. What's going on here? What's going on here? I'm starting to wonder if my multiple installs of .NET are problematic, or the fact that I've got a lot of preview builds on here. That could be an issue. Because this just runs .NET restore, which shouldn't be that big of a deal. Does not contain. Is this a, oh, this is because I included this see, I started this project in here and it caused errors. Can I just straight up remove it? I think if I remove it from the solution, that might fix my problems. So my new project causes it to error out because reasons. Let's try this one more time. Could not find suitable MS build instance. Oh, that's exciting. Why did that happen? Well, more importantly, can this guy compile now? Okay, so this guy compiled. Do you want to use AI assisted? Yes, please turn that feature on. Ooh, it'll do C++ too? Oh, IntelliCode, you make me very, very happy. Okay, so you built, you're happy. I just want to see the output of this, right? Like I want to know what all, because I'm thinking that my copying of the injector bits is probably problematic, and that ultimately there's probably a few extra DLLs that are like I'm guessing it's a dependency problem is my first thought, right? Because there's all this stuff. And I'm kind of just thinking if what is buried in here? Are you going to embrace C++? No. Definitely not. I hope not. That would be bad. I don't like C++ that much. I'm spoiled. I like not thinking about memory and being able to think at high levels. I don't like having to think at really tightly nested levels. So in here, Snoop core DLL is Snoop, but Snoop core DLL also exists out here. So I'm kind of thinking I'm gonna do this. All right, I'm gonna take all of this pretty stuff, all the stuff from its outputs. Right, I'm gonna go to my bin debug. Right, where I've got clearly way too much stuff in here, and I'm just gonna paste it all. Just arbitrary paste it all. Right, everything should be the same version, and then I'm gonna go back to my other solution. Right, and I'm going to change one teeny little thing. So we're gonna do this, and I think we just do this, right? Just everything's in the same directory. No thinking involved, right? And then I think we come here and we change this. Oop. So rather than being here and being underneath the build directory, we go bin debug. Yeah. And fire this off. Was that not part of the stuff that I copied? Snoop injector launcher.64.exe. Okay, I know I'm dumb, but let's try this again. What did I do? So let's try. Come on. Up arrow's not a hard operation. So cd dev snoop CLI bin debug. Net core app 3.1 is missing. Okay. No. Cursor there, please.
and paste and back. Try that. Okay, so it looks fairly similar to what we got before. So it tries to inject it, successfully loaded. Received bad thing from injector component, which doesn't leave me with a lot of confidence. Why? So I guess the question is, what is that error? Right? And why do we get that? So we get a remote handle. All right, so this is where load library. Yeah, just find all references. Take me to where it calls. So it does this. It's interesting to me that it loads it in and doesn't use that same handle. Why did it go to all of that effort to get a handle and then not use it? What handle was it? Remote handle. Module handle in foreign process. It feels like something that needs to get used. Okay. Get remote process. Injector DLL. Right? Execute in default app domain. I'm wondering if this is part of the problem, right? Like, is it expecting to find this and the fact that it doesn't exist in mine a problem? Process name, proc name, get remote proc address. So I'm guessing that must be in the native code. More importantly, it did receive an address because it was not uint pointer 0. Because there's when you don't see much uint pointer. Normally it's just int pointer. Okay, so create remote thread. Let's see, it takes in a process handle, which apparently is being passed. LP thread attributes, which apparently we are sending 0. Stack size of 0, and then start address, remote address, creation flags, thread ID. Okay. Does all of that. So if the remote thread is 0, log this output, which we did not see that, therefore we did not get into this if. So we know that guy returned a non-zero pointer. Wait for single object. So it's going to wait for the remote thread. Get exit code thread. Result from execute in default app domain. And then this guy here received blah. Result exit code from app domain, which I believe we do see. Received that from injector component. Received that from injector component. So get exit code thread. This comment seems highly misleading. Get handle of loaded module. I'm pretty sure that should be there, but maybe I just don't understand this code well enough. All right, and then this should throw and get exception for HR. So it passes in the error code, converts it to int64. So what did we end up? File not found exception. All right, so I think I'm going to do do a little testing here real quick. So just to confirm, this is inside of Snoop. I guess I do need to use this still. Yeah. var ex. So we're going to come in here, throw ex. And I think what I would like to do is log message. Right? We'll just make it obvious that this is not for general purpose consumption. String the exception, and we'll log it out. Because I think what I know is that it's a file not found exception. I think that's what I know. And I think, if I remember right, file not found exception, right? I thought this guy had a file name. Gets the name of the file that cannot be found. Right. So we're going to also do this. If ex is file not found exception, file not found, right? Log message could not find file not found file name. We're going to give ourselves a little bit of a hint because not knowing what that thing couldn't find is a bit problematic. What are you unhappy about? Insert line break afterwards. Yeah, there's also a large number of analyzers turned on inside the Snoop project, so it's very consistent code, which I don't mind. It is good to have stuff. Okay, so you guys, something should show timestamps there about at 9:51. Great. We're going to copy all you guys back into here and just replace everything. And then we'll relaunch this guy, right? Because we are going to run the guy directly inside of where we are. And actually, I guess because we're already inside of this directory, we should be able to do just that, right? Everything should be local. And because it's PowerShell, that's not a thing. Okay. So here's my message. The system cannot find the file specified. Could not find empty string. That is crap. That is not helpful. Apparently, it couldn't find something, but it doesn't know what. Or it doesn't want to tell me what. That's exciting. Okay, so let's go and hunt something down. Get exit code, right? So kernel 32 get exit code thread. This is the point where we go and say, what the heck? Kernel 32. Kenny, this is why log messages are important. Amen. And more importantly, why they should be good ones. Okay, conveniently though, even the pinvoke stuff is at least well documented. It's going to be ugly, but it's well documented. Okay, if the function succeeds, the return value is non-zero. I'm sorry, what? If the function succeeds, the return value, not the output. Return value. This guy is a bool return. Non-zero. So in native land and secretly in the runtime for C#, bool is defined as false is 0, true is not 0. So this actually works. The function returns immediately if the specified thread has not terminated and the function succeeds. Status returned is still active. The thread has terminated and is one of the following. The status returned is one of the following values. Now, when they say status, I assume they must be referring to this second parameter, this LP exit code. Thread termination status. I'm going to guess that those are there, right? The exit value, the specified in the exit or terminate thread function. The return value from the thread function. The exit value of the thread's process. Well, we can conclude, well, no, because the app is still up. The app is running. Oh, that might be interesting. I'm just realizing we could get the standard out from this process, and that might give us more information. Add that to the back burner of ideas. The get exit code thread returns a valid error code. Should not use still active 259 as an error code if a thread returns. Oh, hey Kenny, take notes. When returning exit codes, do not use 259. Just hypothetically. Wow. Aha, he's the old the old 259 rule.
Yeah.
With a wait duration of 0 to determine whether the thread has exited. Ah, so this explains this method that we were doing, right? Ha. Use the wait with a wait duration of 0 to determine whether a thread has exited. So that explains this guy. Except for this now begs the question, why are we not using the return value from this? Right? Like, this is returning a, right? Like, there's a value here. We should use it for something, maybe? Question? I think. I don't know what good it is to not use this. Okay, I am confused. This code is making my head hurt. Hang on. Confusion is completely eliminated. Okay, so if a thread returns blah 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 with a wait duration of 0 to determine if it's still active. Okay, so it seems like this is what was attempted to be implemented. Okay, so but we still have the question of this went to invoke, right? So I'm wondering hypothetically here, if this did successfully invoke, right, the method, and because inside of here, there's all of this stuff that could go wrong, right? And I'm wondering, oh, this is also returning -1. If this returns -1, and the value I see here happens to be -1, maybe it is successfully running my code, hypothetically speaking. So the question then comes, how do I know? How do I know? I would need to put something in this method because it's very plausible with a non-zero exit code. There was probably a reason I did this. I don't remember what it was. It might not have even been a good reason. But I thought I had a reason when I did this. This is the problem when I've let too many weeks go between code A and code B, is I have no idea why I'm returning a -1 here. Okay, so here's what we're going to try. If in the hypothetical situation, this is in fact the -1, this will work. We're going to try this because this is quick and dirty to try. All right, so we will rebuild this. Let's see, you go away. Where's my... Oh. It's probably going to fail to build. Because, it is going to fail to build. Because this process that I have running over here, right, has actually loaded those DLLs into memory. We got further. We got further. Never has failure looked so good. Okay, the problem being is now I have to restart the app, which unfortunately means I need to get the process ID, and I don't feel like looking this up every time. So, process. Come on, autocode button. Figure it out. That ain't it. Try that one. Get process by name, and you are going to show up as material design demo.exe. Design demo.exe RP. Wait. Oh. Single. I'm okay if you crash spectacularly if it's unfound or whatnot, right? Blow up in big and exciting ways. Okay, so process ID. Okay, now I don't have to think as hard, and it'll just look it up for me. So, oh, I probably should have clicked yes. That was the IntelliCode button, wasn't it? If I do it again, will you pop back up? Pretty please? Oh, I'll have to go find the switch and turn it on. Okay, so up he goes. Sequence contains no elements. Oh, what the heck? Oh, the process name doesn't include the exe. That's right. That's right. I remember now. Just want to see you work once before I just immediately assume. Okay, perfect. 42888, right? And I'm just gonna go back here. 42888. Okay, so let's try this. This did not give me a 42, which is interesting. Okay. 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 I understand. So now my next instinct is I want to look at what's happening inside this process, right? And I suspect, so we're gonna, oh hush, I know I clicked the button before you were ready. So go ahead and start the demo app, and more importantly, so we're just gonna, I don't care about, I just want to close all tabs. Give me back my menu. Close all tabs. So specifically what I'm interested in is watching this here, right? Because there is output that you will see. Like, so for example, proof is in the pudding, right? So Snoop works, right? So if I take Snoop, target this app, and do this, right? It opens. But more importantly, you see output from Snoop once it gets injected and running inside my process's memory space. This is writing to the standard out of the process I just started with my debugger, right? That is cool. Very cool. So, but more importantly, this is what we expect to see. So let's just, I'm going to put this over on a, I'm going to just put this on a spare sheet and put that to the side for a moment. Okay, more importantly, I'm just going to restart as well, just to make sure that I'm in a clean state. Okay, and then Let's go back over here. This guy. And I just want to grab the CLI because all I care about is getting my PID. Actually, here's what we should do. We should take the PID. Okay, go away. Process. Grab the ID, and I'm just going to pin that. All right. 39992. Great. Kill. Let's see. Up arrow. 39992. Okay, so he's going to run. Huh? Let's try this again. Color me confused. File not found. What is this thing? Why are you now suddenly a thing? ATICFX32. My Radeon's what? I'm very, 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 very confused. Hey, Metal Slug, how you doing? We are having fun with Snoop and trying to make it. Well, the short version is I'm trying to get the Snoop's injection mechanism pulled out of the library so we can use it elsewhere. And apparently my graphics card driver is now an issue, despite the fact that it wasn't a problem a second ago. I am okay. I am very confused. Let's try something slightly different. Let's just do this, right? That's now a thing. Let's check the PID 23840. So we come back over here. 23840. Go. Kenny, your confidence is astounding. Thank you. I'm just very confused why. So, hold on. Snoop injector launcher pro. Hold on. Hold the phone. Snoop injector launcher. Okay, so here's what I want to see. I want to see this execution before we do it. Okay, so what is the start info here? Are we passing something stupid? We are passing. Okay, locals. Yuck. Okay. Visual Studio, you're getting annoying. So we'll zoom in. Okay, aside from the text being all non-happy. So we're passing the path to the assembly. That path looks correct. Okay. The class name also looks correct. The method name looks correct. All the parameters appear to be there. So for the command line, it is passing an assembly path. Let's jump out of here. Right? Target handle. I have a thought. Both times I've done this with Visual Studio. Let's let's not do Visual Studio. Let's double click. Right? No fancy Visual Studio tricks. Okay. Keep it simple. Keep it simple. 39404. Oh, look. 404. Insert irony here. 39404. Okay. This is better. This is much better. We're back to where we were. So something about launching with the Visual Studio Debugger is a bit of a problem. Something with the Visual Studio Debugger is a bit of a problem. So I've got a couple thoughts. My initial thought is that I might not be getting into my code. And I don't know if I'm getting into my code. So here's what we will do. Great. Kill execution, right? So what we will do, and I don't need that stupid piece of stuff anymore. Let's do this. On the callback, right? Let's just get rid of everything, right? Leave the return code because I think we need it, right? File, create, success.txt. And actually, can I get away with, I think I can get away with this now. The type name create. What? Oh, is it file open? How about open right? Are you just being dumb? Something about that syntax tells me it should work, but using file. Okay, now I have to. Interesting. Okay. So, and just to right, does not exist anywhere on my system. So, if this now works, we'll know that we're actually getting into our callback. Something in here is blowing up and our world's over. Which sounds reasonable, right? I'm sort of wondering if, let's see, processes. See, it's locked by the process again. So I suspect that we are hitting this callback. Okay, so once again, proof is in the pudding. Still doesn't exist. Okay, we will. I guess I can just launch this. There's no reason to. Well, the command line gives me the output. Bah humbug. Let's see. 45316. So again, just gonna. Okay, good. Let's see. 45316 and go. Received 0 from injector component. I'm wondering if this callback is supposed to block. Now I'm curious if the Snoop one on their callback, if they block and pop the window open. Because the thread is being allowed to exit. Receives 0 from injector component, right? which means this int isn't being used for the exit code. But now I'm questioning. Well, hold on. Just. Okay, we are getting our callback. Insert success here and maniacal cackle. Okay, so we're getting all the way in here. We're just now blowing up on the injection bits. It would be great to debug this. It would be very, very good to debug this. How do we go about debugging this? Think. So, hold on. First of all, I want to go back to Snoop's call, right? When they do their injection. So I'm pretty sure I blatantly just stole straight out of their methods, right? Like this should look very, very simple, right? I changed out some of the parameters from rather than this injection data bit because it had extra stuff and I passed strings around and whatnot, but this is basically the same stuff. So what I'm very curious about is what do they do on their callback? Do they block? Because I'm wondering if my call is expected to block. Because by letting that method complete, it appears to let the thread that they spun up die. Which isn't horrible. It's not horrible. That's not a bad thing. I'm also wondering what's going to happen if I ever run into a case where somebody references the same dependency DLL I have. That could get interesting. I don't know how it handles that. So I want to know where your callback is coming from. So we'll just chase the bunny upwards. Find all references. Find all references. Yeah, I want to know. Show me who uses you. Somebody's setting a method name or similar on here, right? New item. Okay, class name, command line options, method name. So, find all references, because I know something about this library. Again, this should hopefully look similar to some people. Find all references. This, I'm pretty sure, is just coming from right here, which is coming. Find all references. Okay, Snoop Manager, start Snoop. That's what I'm looking for. Okay. So they return either 0 or 2 and a 1 on a failure. So start Snoop instance. So what do? You do a lot of stuff. So it loads some data from the settings file, right? And this is what I was saying, that how when you attach Snoop to something, why you end up getting this information here, starting Snoop, right? So when Snoop attaches and the callback gets executed inside of my process's memory space, this gets run inside of my process. It does some app domainy stuff. Run in current app domain. So if number of app domains is less than or equal to 1, hang on. I'm trying to see if I'm just being stupid here, but this isn't possible, is it? Same variable, less than or equal to 1, equal to 1. Pretty sure this is unreachable code. Okay, so running in app domain. So we're going to assume we're running current app domain. Just going to drop a bookmark there real quick, just to keep track of it.
We may jump back. Jump down here. Message box. Is this WinForms? Windows message box. So this does error messages. Blah blah blah. Set. So this is the multi-app domain stuff. I don't think we're gonna be hitting that. So we must be running current app domain. Do you block? That's all I want to know. Do you block? Inject Snoop into dispatchers. So this does a thing. There's a callback to create the Snoop window. So let's go into here. So this does some stuff like most messages do. Instance creator. So you're going to get invoked, right? You build up root windows, do some stuff with the windows, blah, 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 blah. Dispatcher invoke. This will create a window. This will start a thread. This will return. So it doesn't block. I mean, at least not indefinitely, right? So, because this would grab the dispatcher invoke, create a window, right? That's all the instance creator was doing, was instantiating an object. This guy here then's going to do some stuff with a target, find, and target the appropriate window on there, right? So populated, but it's not like well, let's just confirm that. So find all references, right? Create Snoop window. Snoop window inspect. Just waiting. Yeah, show activate. Those aren't blocking calls, right? Shows the window, activate, it pops it in front, which is why your Snoop window usually sits on top of everything, and the setting the owner will ensure that if it finds the window you targeted, it always sits on top of it. So we don't need to block. I guess then the question is, what should we do once we get inside, right? So they ultimately spin some threads, look at dispatchers and all of that jazz to do fancy stuff. I tried to do this. And this went boom. So I guess the question then is, why did it blow up? And what to do about it? I guess what we just... So I think my first gut level instinct is to start simple, right? Strip it down to just the bare minimum. We're gonna catch exceptions because we're clearly getting into this method, right? We know that. This whole launching code inside of a different process's memory space kind of makes my head hurt a little bit. But I'm thinking what we do, I'm going to leave that guy. Oh, I got it. var file stream, right? And I'm just going to oh, that's why, because I didn't declare a variable, so I couldn't use the new syntax. Got it. It's new stream writer, fs, sw, right line. We need you to be synchronous, ex to string. So we will just... We'll just be, if there's an exception when we do this, which there might be, right? We will just blindly go through and write it out to my new happy file. Okay, so we'll compile that thing. I'm going to kill the app and relaunch it each time, just because if we are loading stuff into its memory space, I don't want to have a past run corrupt it. I think that's probably reasonable. Let's see what happens. I'm trying to think if it's better to just run from the command line. I think it might be 36604. I think this output is helpful, at least for now, until I'm confident that my other app is working. 36604. Cut the number of variables out. So that guy there, color me confused. Always thought it was weird how C-star uses using instead of just disposing when it goes out of scope. Yeah, and that's ultimately the problem that they tried to solve with C#8 and the new using declaration. Or, no, that's not the word. So because there's using declarations, statements, and expressions. Using expression, I believe, is the term for this. Because if you do it like this, then when it falls out of scope, it gets cleaned up, which is great. That's kind of what you want, like 90% of the time. There are like edge cases where I have wanted to like control exactly when dispose gets called, and so if you need that, this doesn't work and you have to go back to the old syntax. But most of the time, this is all you want, right? It's pretty simple. I'm wondering because if it is a file not found exception and it's blowing up before I get to here now, but it doesn't blow up if I do this. Right, so let's do this. Oh, this has probably got it locked again. So I think it is. So yeah, I think I actually know what's happening, which is a scary thought. So if we look here again, 23348. 23348. If we run this, right? It thinks hard, I guess. So my working theory at the moment, and we'll see if this ends up timing out or what the deal is that so C#, or I guess technically the .NET runtime, when it goes to load an assembly, when you fire up a program, it doesn't load all of the referenced assemblies immediately, right? Because that would be a big hit to startup performance. So in an effort to be smart, it waits until it actually comes across code that's referencing something in one of those assemblies, and then it'll load it. That way, if you load something up, it's not trying to just load all the referenced assemblies, because that would take forever. Hello? I don't really know what happened there, so I'm going to just kill everything. And I'm tempted to check for an injector launcher process, A, B, C, D, E, F, E, H, I. And so my theory right now that I'm tentatively working off of is that it is failing to load. It is failing to load in the .NET Interactive DLL, which is why it would give a file not found exception, because when it would go to launch this method, that would be the first point where it would come across some type from that referenced assembly, and it would then attempt to load that assembly. If it fails to load that assembly, it's going to crash out, but it's going to crash out before it actually gets inside of this method. So it would die before getting here. We could test that theory. If I move out the .NET Interactive out of this method, allow me to get into my callback, right? effectively be able to write this and then handle it elsewhere. That would be an idea. That is an idea we will circle back to momentarily, right after I confirm if this guy's actually going to launch correctly for me or not. Back over to here, back up to here. Right, fire up. New PID is going to be 37360. 37360. Launch. Okay, so you'll note it did successfully run now. Success txt creates, but it is unfortunately an empty file. So, given that information, I have a feeling that is what's going on. So, if that is in fact the case, let's see if we can confirm this. So, I believe if I just move it into a separate method, that will be good enough. It might need to be a separate type. No, that would not make sense. This guy here is here. Void do .net interactive stuff. Boom. Right? So we're going to just take all of this, right? Grab all of you, put you here. And now, so if I am right, the behavior I would expect to see is I should be able to see my success flag get written, right? And then I should see my success flag or my success file get written, but then the same exception get thrown, but probably caught, right? I believe I can now catch it and handle it here. SW, well, the fact that so we know we're hitting this exception block if it writes to my file, because nothing else should know about the file to write to it. Beautiful. So do that, compiles, launch the demo app, grab the, oh, apparently I closed you, need my PID back, pretty please, 46628, let's try this again, 46628. That's interesting, but that would line up. There we go. There we got the exception. Huzzah! That was, in fact, the problem. So it is failing to find this guy here. Okay, now we have an explanation. I don't know why it can't find it, but this is, so short version, we do have Snoop effectively injecting into our process, loading our assembly, and calling our callback, right? That much, it might be worth a pull request back into Snoop's library, because I know I'm not the first one who's wanted that level of functionality. Now, the problem being is now that we're getting our callback back, what do we do with it? And clearly right now we blow up. Got it. I know what the problem is. Default assembly resolution for an application looks in the current directory alongside the, so it looks in the current working directory for the assemblies that it needs. The problem is this code is no longer executing inside of our app, right? So right now, yeah, Snoop CLI. When we start running, we are inside of, you know, our bin debug directory, right? But this callback is invoked inside of this guy's memory space. And his working directory is over off in this folder. And this folder doesn't know a darn thing about any assemblies back over in this folder. So I think the solution is we need to manually handle assembly resolution and tell it to also look inside of this directory. I think.
Just trying to run the process through my head to make sure I'm not completely crazy, but I think that's is what we need to do. Yes, that is what I think we need to do. So my next thought immediately out the gate is, how the heck does Snoop handle this? Because they have to run into this exact same problem, right? And it would have to actually be in the start Snoop method, right? There's no other, somewhere inside of here, this guy has to register up to handle assembly resolution. I have to believe it's in here. Attach assembly resolve handler. I'm going to go out on a limb and guess that it's right bloody here. So this is what they're doing. They're being specific about their assembly. I think I'm going to be a little more aggressive. So we effectively need to do what this guy is doing here, right? Oh, interesting. They have a static method that shows a dialog. Huh. I guess the assumption being that they're always inside of a WPF application. So, okay. So once again, I'm going to just drop a bookmark. So Control KK for those people who miss it. Just lets me mark places in the app. So this guy here, they're just grabbing app domain, current domain, and doing this, right? So I think we're going to steal this. Right, back to my code, back to my code. And we're going to do something similar. Boom. Ditch that. Right now, I'm not even remotely concerned about that. I am wondering if I'm going to run into this problem. System management automation. We're going to comment this guy out for now. And we will just ignore it. So, because I think what we're going to end up doing is just checking our current directory. Where is this getting it? Get PowerShell assembly path. Huh. I'm not entirely sure what that's there for. So we're going to ignore it until I know what it's there for. So obviously we can't do this because this is not a thing. But what we could do is interactive, right? Like, because that is the assembly that is executing at this point. So we could do here. If file dot, so let's see. We'll do another just quick resolution check. So assembly name. Let's see. What is it? New assembly name? Is that how you do this? I'm trying to remember. There's a fancy way to parse one of these things, and I think you can just do args.name, right? Believe that. Yeah, you feed in an assembly name and you get an object that you can then look at. Var name, right? So if file dot exists, let's see. I think we just do current working directory. Good enough for now because we're forcing everything there. Let's see. So this is going to be the file name of name.name.dll. Return assembly load from. So let's just break this out real quick. Our DLL path, right? Except for the fact that DLL is usually spelled with 2 L's, not 1. And load from DLL path. Okay.
try that. Same song, next verse. And let's see, we're going to clean out our little logger. And we need to attach assembly resolve first. So app domain, current domain. We're just going to do this because I'm not concerned about handling multiple app domains and all of that jazz yet. Like, this is step 1. Get it working. Step 2, get it right. Step 3, make it fast. In that order. So this is the get it working portion of the show. Let's see. So that'll go there. That'll go there. I'm kind of tempted to just put this code back, since I know this code largely matches, and actually app dot didn't this guy have used WPF? Oh, it's because it's not app, it's application, because we don't have a generated app.xaml in this. System Windows Forms app.current. Something akin to that. Something akin to that. I'm somewhat tempted to write a little logger thingy-mabobber that always just spews into my file so I can do printf level debugging, but we're just going to go for gold. Just going to go for gold. Okay, so start up a new instance of the app. Close Notepad because reasons. Make sure we're empty. Good, we're good. Everyone's happy. 33784. Let's see, clear output. 33784. Go for gold. Oh, we are running, I think. Tempting, tempting, tempting. What are the odds, hypothetically, that this just works? They're low, but I'm somewhat tempted to just try it. So let's see. So this is going to load up interactive. This is probably not right because I also want to grab the... Yeah, we're going for gold. Connect. Is there a named pipe listing? System says no. Pipe name Snoop.interactive. Sorry, I just want to make sure that we actually... I didn't do anything stupid. So let's see. Composite kernel, register C# kernel, blah blah blah, middleware. I'm trying to remember where all this stuff is. Where all this stuff is at. So there's some dispatchery stuff. There's this stuff. There's this stuff. The dispatcher isn't implemented yet. Named pipe name. This is hard coded to Snoop Interactive. So there's no way that missed. So that theoretically should have launched. I guess, hold on. Exception was thrown. Could not load file or assembly. So same error. But I'm guessing we... Okay, so here's what we're going to do. Okay. So let's close this down. Okay, one more shot. You stop. F1. Restart kernel. Okay, so let's go back up here. I think what we're going to do is action string log. All right. We're just going to give ourselves a callback. Let's see. So log something like loading args.name, something like that. Log, let's see, using local assembly, something like that, and then log. I think what we're going to do is we're just going to go down here. Log found DLL DLL path. Excuse me. Oh, this isn't going to work for the same reason the other one didn't work. This is the wrong base directory. This is the wrong base directory. I need to get assembly, get executing assembly. So I think we always want executing assembly. Right, we're always going to need this. For Snoop interactive gets that. Right. Snoop interactive. Right, but this is not going to work because let's finish the logging. We got to change the location to look in the same folder as this. Failed to find assembly DLL path. Right, so because we got to change its directory of where it's looking. Okay, so this is going to become path combine of path get directory name of Snoop interactive location and then this. Right, so that goes there, that goes there, that goes there. Something like that. And then we're always going to get a log output regardless of whether it finds it or not. This guy is unhappy because he needs a log. Let's see, so let's just take this guy here, move you up. And this becomes x lambda sw right line x. Something like that, right? That gets me to there, that gets me to there, that gets me the logging I want. I think this change here might actually get it working. So now we always expect this file to have stuff in it because we are going to be loading assemblies in it. So rebuild, demo app is down, relaunch demo app. Come on, if I can pull this off before 11, that would make me really, really happy. Be a very good night. 29184. Clear output. 29184. Launch. Okay, did something. Let's check our debug output. So it went hunting for a whole bunch of stuff. Found all kinds of DLLs. So more importantly, it did load Microsoft.NET Interactive this time. Okay, so that means the name pipe is theoretically there and listening. Which means I come over here and I click connect and come on. Don't ruin my happy night. Grumble, 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 grumble. I'm wondering what my kernel name is set to. Let's check that. Oh, we're so close. So close. Where is the kernel? Register C# kernel. What name are you using on your kernel? New C# kernel. What does this do? I thought there was something I had to set up to give the kernel a name. Because I can see this guy, so the pipe name is there, right? Connect name pipe, kernel name. Oh, this kernel name is what this local guy uses for his kernel. So if this is failing, Snoop Interactive might not be there. So let's get us some logging into here. So action string log. Right, so let's go into here. This is not quite going to be good enough for what we want, right? Because this is preemptively just referencing some assemblies and loading up particular namespaces, which this is fine-ish, right? We're going to want this, but we don't want exactly this. I'm more interested in, wait, what starts the named pipe? Use name pipe server. So we're going to come in here, log, and I think what I might actually do is this, right? I'm gonna try catch this because this is often its own task. Ultimately, this one probably should be a thread, maybe. All right, so log e to string, right? Make it be so. So how about log started named pipe named pipe name, right? So this is use name pipe. Oh, this is working directory. What is the appropriate working directory for this? Because this is going to give me, I don't know if it matters, right? It'll matter for code that gets executed as part of .NET Interactive, right? What its working directory is, but it shouldn't affect my ability to connect to it, I don't think. Diego, John, I need your wisdom. Okay, so let's make sure we at least get to this, right? So this should get a bunch of stuff wired up. This should get a bunch of stuff wired up. Okay. The other thing I wonder is if I could theoretically redirect standard out from my WPF app and feed it back through to my console. That would be another fun trick. Don't know if that's always going to be the case, but most WPF apps probably aren't doing fancy stuff with standard out. So, might be a worthwhile switch to turn on. Not my problem for now. So we are going to once again x lambda sw right line. Poor man's debugging is great. Whack our little guy here. Let's see, let's kill this. Build. Close this. That's happy. Relaunch. Come on, baby. I want to see a name pipe start. That would make me so happy. 45612. 45612. Okay, so it did all of that. Succeeded. Let's look and see. So that's not a good sign. So even though it got through all of this stuff, didn't throw any exceptions. However, we never got to our log message about starting the name pipe, which is why we aren't connecting. Suck. Okay, So let's go back. When in doubt, check what the wise Snoop does. So you are no running current app domain. Let's see. Inject Snoop into dispatchers. I think this might be what we need to do. So instance creator. This is just changing. This is just literally returning a delegate. Okay, I don't care about you. This injects Snoop into dispatchers. This might be what I care about doing, especially since I want to ultimately be able to control how this works. Use multiple dispatchers mode. This is a lot of work for finding the root visuals and dispatchers. Let's see. Root visuals count 1 or don't use multiple dispatchers. This is probably the case we're walking into. This attempts to create the instance using the dispatcher of the root visual. I don't know if I need that. Do I need that? Do I care? I don't know if I actually care. Right? I think that's probably fine. So use multiple dispatcher mode. It spins its own thread. We don't care about that. User didn't want to enter multiple dispatch mode. So they do fall back to application current dispatcher. Instantiate their window on the dispatcher thread, which this sort of makes sense why they would have to come back to this, because here they're very much like for Snoop, it's wanting to open a window, which needs to be done on the GUI thread. Right? Like that. It kind of makes sense. I'm just curious if I need to do it. There's not a lot of it's like I suspect I'm going to need to do it at minimum for the dispatcher on off, but I should be able to get the named pipe working without that. So back to basics, right? So let's see. Let's look up. So I'm going to once again move this over into a useful. Oh, not what I wanted, right? Stop. Restart kernel. What I'm interested in is the things that it failed to find. And are they going to be a problem? The only one it failed to find was Visual Basic Features DLL. I'm kind of okay with that. I'm thinking that's okay. I'm thinking not finding Visual Basic inside of a C# app is okay by me. Okay, so there is still a problem in that when we started this, we didn't get into here. So what do we know for certain? We know for certain that we got into this method because it started resolving this guy's stuff, right? So we know that happened. The task.run gets started. Oh, but I'm betting our thread drops off and it dies. That's a problem. That is a problem. I bet you that's what's going on, is we're starting a thread in this process, the thread dies and brings down everything with it. Which, if this is being started in its own thread, the theoretical simplest option is this, right? Now this may not actually work, but it'll at least prove that we can get down and start this. The problem being there are async methods in here. So let's do this. Async task, right? We're gonna go all asyncy on it.
right? And this guy here, I'm going to do a wait. Please do not throw things at me. Because I honestly have no idea. This remote thread that's being created, I have no idea what its execution context is. I'm very confident it will not be it'll not have the synchronization context of the UI thread. That's the only thing I think I know for certain. Okay, so this should get me to starting a named pipe. Because now we're no longer spinning extra threads. It should either throw an exception, which would get logged in one of these places, right? Technically, this is kind of meaningless now. So we'll let this thing throw, right? Just let that guy repropagate up. Okay, so we're going to launch this. We are going to make sure our file is clear. We will check our PID, 28580. 28580. We'll launch it. Right? I'm guessing that slowness is when it's doing the assembly loading, because that is not a quick operation. Okay, so that's there. If we come into here, I want to see so the C# kernel run async tried to run some code, specifically the set variable async, and it failed. One or more errors occurred. The type or namespace material design colors could not be found. Are you missing a directive or a blah, 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 blah? What's interesting to me is that this appears to have occurred without hitting our assembly resolution bit, which tells me that the problem is we are not on so we must not even be part of the main app domain, right? Because if we were part of the current domain, our assembly resolution handler should have fired, right? But apparently calling this, specifically accessing app.current. Regardless, this is optional for getting a named pipe working. Okay, same song one more time. We are so close. So close. And whack that guy. And restart. Okay, so we got that going. Files whacked. PID is 31180. Back to here. 31180. Load that up. Okay, we check here. Started named pipe. Huh? Go for gold? Booyah! It's working! Oh, that makes me so happy. I know, so I realize this is a lot of work for getting the simple answer of kernel added. But this, believe it or not, is a significant endeavor, right? We were able to use Snoop's injection code to get inside of a running WPF application, invoke our callback to start up dotnet interactive, right? dotnet interactive fired up a named pipe. We were then able to connect to it with workbook. happiness, happiness. So ultimately, the bit that we were doing from the command line, doing this start and this NuGet reference, ultimately this will, once this gets packaged up, this Snoop Interactive gets packaged up inside of a NuGet package, we shouldn't need the CLI anymore, and we should be able to do this to any WPF app simply by creating a new one of these workbooks, referencing our NuGet, and feeding it the PID of the thing we want to attach to. Yeah, it's that level of cool. I think it's that level of cool. Because after this point, then it should just be a matter of going through and you can do stuff that you want. So, for example, let's see. GitHub.net, I think it's interactive. Did I land? Oh, yes. So there is a sample over here that I may have had something to do with. Right? So if people are interested, this is actually out in the .NET Interactive Samples. There's that guy there. Inside of app.xaml.cs, you'll note this code should hopefully look very familiar. This was previously being done inside of on startup. Good to know. So it was doing all of this effective work, right? The key part is it injected the app as a variable, and then it also went through and set up this enabled flag for the dispatcher, so you could choose whether you wanted the code from VS Code to run as on the UI thread or not. So there was that with a default value of true, obviously. And then what the workbook looked like is this guy here, right? So you would connect up to the WPF app, right? So you make sure the WPF app is running. This will do all the things. You do the connect. And then there's examples doing formatting, and you can just do app dot because of that add variable that was being done inside of it. So ultimately, we can still do that. But I don't think I'm going to be, well, I'm connected. Let's see. How bad could this go, right? So application current, or can't I do a dispatcher? So current, I think that's a thing, right? So let's look. So you'll note I'm actually getting IntelliSense in there. If this thing had properly done more using statements, my IntelliSense would be based on that. So I think we want to do, so let's see, what is this? System Windows Threading Dispatcher. Let's just bring that in. Using system.windows.threading, right? Var current dispatcher gets dispatcher current. Isn't that what we just saw? Current dispatcher. I don't know why I'm not getting IntelliSense all the way through on that, but system Windows threading doesn't exist in, oh, am I missing an assembly reference? That is a very good question. I don't know what assembly that would be in that isn't already being referenced. We're gonna ignore that for the moment and assume that I can retrieve the current dispatcher. Right? Current dispatcher. Then I'm gonna go cd invoke. All right, do something like this. Var app gets application dot current. This guy. I have no idea how much of this is legit versus what's going to blow up in my face, but this is the type of stuff you could then do. right? So this should get me here. Whatever, let's run it and just see if we get this far. Oh, so it turns out the warning here is legit, and system windows. So it only knows about input and markup. Interesting. So I will have to track that down and figure it out. But the key part is it's connected and it's working and it is awesome. So, and then we will have to play around with this because I don't know what this is going to do if you like try to connect to a WPF framework app and have it reference a .NET Core WPF library. That feels like there feels like there's edge cases that are going to blow up. But the important part is it's working, and it worked. So that is where we are going. Hopefully, now that I've got this more or less in a working state, I'm going to see if I can find a good place to push this code up to, because I don't want to lose this. I just don't know where I'm going to keep it. So I might ultimately end up ditching this CLI in favor of just, well, I don't know. Maybe I'll leave it. I got to find a place to put all this is the short version. So, and I don't know where it's going to go. It might just have to go in its own repository for now and just sit there. And I got to restructure some projects in the solution file and all that because it's not properly nested at all. But it's working. So, cool. With that, I'm going to say thank you, everyone, for coming in and hanging out. I had fun. Thank you, Kenny and Metal Slug, for chatting along and at least trying to mildly encourage me as I fail miserably. But it's working, which, once again, is the most important thing. So I will say see you later. Happy coding. Talk to everyone next week.